That is perfectly correct, and I'm looking forward to an interesting 45 minutes on this topic. Private endpoints and friends, two things that seemingly don't go well together, privacy and public cloud, but we will see. It will work pretty well. Just before I get started, let me check. Do you see my signal? Everything's fine? Everything's streaming as properly? Okay, so let's get started. Let me quickly introduce myself before we dive right into the topic. My name is Rainer Stropek. Thank you, by the way, for this nice introduction. I am a passionate developer. I love coding, and nowadays coding also means DevOps. So in the last 10 years or so, I have been using Azure, various systems here, and the Azure cloud is my second home. So whenever I run and build software as a service solutions together with customers or for my own company, I run them in Azure, and therefore I thought it would be a good idea to share some findings and learnings with you with regards to privacy in the public cloud. So our topic for today's session is private endpoints. If you would like to stay in touch with me, you can do that in the most easy way by going to this website, rainerstropek.me. That's a kind of digital business card of myself. You see a short bio here, and at the right lower side, you see it here, you see various links to social media platforms, and I would love to see connections coming in from your side. If you use LinkedIn or Facebook or Twitter or whatever, I also run a pretty active YouTube channel with various technology items, including sessions about Azure and so on. So if you like, take a look at my YouTube channel, and if you find it useful, subscribe. The session today will have no slides at all. We will just look at demos. I love to do demos. I love to show demos. And if you have any questions, please don't hesitate to ask them in the chat. But one thing is important when you do a live demo session like the one today, you have to share the demo code, because maybe some of you would like to recap what you see in the upcoming minutes, and therefore I would like to share the demo code with you. It's on GitHub. Here you can see it, and of course I will share this link with the organizers of the conference. So if you want to have this link, the organizers will let the link come to you, or if you need it immediately, just contact me, for instance, via Twitter, and I will immediately share this link with you. So this is the code that you are going to see. Good. And with that, enough of the introduction. We will dive right into the topic. The scenario with which I would like to start today is this one. As you can see, I used a little ASCII art here. We have on the left-hand side here the public internet, and in this public internet we would like to offer a public web API. This can be written in any language. In my example, it is written in C#, but it can be Go, it can be Java, it can be Node.js, it doesn't matter. It's just an API, a RESTful or REST-ish web API, which offers its services on the 443 port. Nothing special here. Now, this public web API does something which is very common in the practice. It accesses a backend private web API. So this one, the left-hand side here, we could call it a backend for front-end architecture, and this one here might be a backend microservice. So let me quickly write that here. That is a backend microservice in my scenario here. And finally, we have a platform as a service SQL database, and here you have to use your imagination. This could be a MariaDB, this could be a Postgres, this could be MySQL, this could be a NoSQL database like Mongo or Cosmos DB. It really doesn't matter, any kind of database. And for my demo, I'm going to use Azure SQL database as an example. And this private web API is accessing the SQL database here in the background. Now, I have a script here, a so-called infrastructure as code script. It's part of the GitHub repo where I create all those resources for you. Why is this important that I don't click around in the Azure portal? The Azure portal is beautiful. It's nice. It has great usability, and it's a very, very nice tool if you are learning, if you are exploring Azure. But if you are really a serious Azure developer and you would like to build production level software in Azure, you should always aim for automating your stuff. You should aim for automating your processes and the creation of your resources, the maintenance of the resources. You could use any technology that you like. Would you like to write PowerShell? Write PowerShell. Would you like to write bash scripts like I did here? Use the Azure CLI. Do you want to use open source software like Terraform? Feel free to do so, or ARM templates or bicep scripts. I don't care what you use, but we are here at a DevOps conference, so it's really, really important to emphasize that professional Azure developers practice infrastructure as code. It's fine to use the Azure portal in the case of problems, for troubleshooting, for, as I said, learning and exploring. But here, if we want to make something repeatable, if we want to have code reviews in practice and things like that, we should always build infrastructure as code scripts. And in my case here, I decided to go for a simple bash script. Why didn't I use Terraform or ARM templates or something like this? Well, because a bash script is really simple to demonstrate. I wanted to show you how I can build my scenario step by step by step. And that's exactly what I did. I have a bunch of variables, not that interesting. And then my scripts first create a resource group. For those of you who are not that familiar, resource group is, as the name suggests, a group of resources which you can manage as a whole. So you can create it, you can delete it, you can set some resource-based access control, you can lock it and prevent deletion and so on. So this was just the resource group. And before I got into this session, I already created this resource group so we don't have to spend time with it. Next, if I scroll down a little bit, I was creating, and you see it here, a SQL Server. That is a managed SQL Server, fully platform as a service, so no virtual machines, nothing like that. I created a managed SQL database. Oh, sorry, the rectangle was not perfectly correct. This is now the correct rectangle. As you can see, I created a SQL Server, that's a logical server, and then I created a SQL database for my backend. This database is in fact a database cluster. So this statement down here creates a cluster of 3, 4, 5 nodes, whatever Azure thinks is appropriate. It is high availability in with auto backups and all this stuff. This is created here out of the box. My talk is not so much about a particular storage system. Here, the SQL Server is just for demo purposes. But again, if you don't use SQL Server, but Postgres or MySQL or Cosmos DB or Mongo, feel free to mentally replace the SQL Server here with your storage environment. The important part, though, is that this SQL Server is currently not protected. It's not private. It's running in the public cloud. So if I go here and if I take a look at this SQL database here, we will see this is the server name that you see here. I will copy this server name and maybe spin up here a console for me, and then we can do a dig on this server name. And if we do that, we will see, oh, that was a little bit large here. We will see that my SQL database is behind a firewall, in fact, but the firewall is publicly available. So this is the public IP address. It's a kind of zero trust networking approach in the moment. So this is what I created up front. Next one were the two app services. I use the Azure service, which is called App Service. It's the go-to service if you would like to run web APIs or websites in Azure. Of course, you could use more elaborate systems, like, for instance, a Kubernetes cluster, either your own Kubernetes cluster or a managed Kubernetes cluster called Azure Kubernetes Services, AKS. But in this case, that seems to be a little overwhelming because I was just going to run two APIs. And if I just want to run APIs, to be honest, I don't want to deal with something as complicated as Kubernetes. So I just used app services to run these two APIs. But mentally, again, in your mind, if you are using virtual machines or if you are using Kubernetes, it works nearly exactly the same. The point here is that I'm using a platform as a service offering here. Platform as a service or serverless offering. So what I can't do, I can't take the virtual machines and move them into a kind of virtual network. That's not possible. Why isn't that possible? Because the virtual machines are not mine. They are ran and operated by Microsoft. It's a multi-tenant service, like a managed Kubernetes cluster or a managed app service or some other managed database. So I cannot simply take these virtual machines and move it into my app service plan, into my VNet. That's not possible. So we have to find a different way. Currently, those web apps that you see here are directly speaking to the database over the public IP addresses. So I'm not having any kind of virtual network here. I'm really running on a zero trust networking approach where the internet is my corporate network. And with these two statements, these are the last two statements that I ran up front before going into the session. With these two statements, I were connecting the APIs with the SQL Server or the front-end API with the back-end API. So the second one is the public web app, you see it here, and it is connected with the private web app in the background. And the private web app, you see it here, is connected to my SQL Server. So I reach exactly the goal that I specified at the beginning of this session. Now let's quickly try these two APIs. The first one, the public. No, let's start with the private web app here. The private web app, what does it do? It's a ready-made Docker container, really nothing special. And what does this Docker container do? It DNS resolves the name of the database server, and no surprise, the database is running on a public IP address. And secondly, it issues a trivial SQL statement against the database. So it just says select hi from this database just to make sure that we can really access the SQL Server. And as this demo proves, it works like a charm. This is running over the public internet, not perfectly true. It's running in the public Azure networking infrastructure, but it's running kind of in the public internet because it's the services are accessing each other over public IP addresses. Now let's take a look at the public web app. The public web app, this is the second one, does the following operations. First, it is returning the IP address of the backend API. This is again a public IP address, and then it does an HTTP GET to the backend API. And of course, the response that it gets from the backend API should be exactly what we have seen before, because I showed you the output of the backend API. So it works perfectly fine, exactly as we expected it. And now our goal is to, let me scroll up a little bit. Our goal from now on is to have more privacy in the public cloud. So what I want to do is I would like to create in the cloud here a virtual network, a VNet. Now this VNet belongs to me, so I can decide what's in it and what isn't. And the first thing that you will recognize here is that my public web API is kind of in the VNet, but also not kind of in the VNet. And that is exactly what I want, because the public web API should have a public endpoint, but the public web API should also have access to the private VNet. So the internet should be able to access my public web API, but whenever the public web API accesses the private web API, the traffic should stay within the VNet. And the private web API, you probably guessed it by now, should not be visible over the public internet. So if somebody tries to access this one over the public IP, it should be forbidden. It shouldn't be possible. Same should be true for the SQL database. No external access. No, only the access through the VNet inside of my private IP range of my subnets that I create inside the VNets. That is the goal. And this is achieved by private endpoints. This is why I call this session Private Endpoints and Friends. Good. So let's scroll down again. I showed you the script until here. And let's run the first script live here. This is the script that I would like to run. And let's get going. While this script is running, I would like to quickly walk you through the code so you understand what's going on. The first statement here is an AZ network VNet create. Yes, it creates a virtual network. Virtual networks are, as the name suggests, networks inside of Azure. In real world, many enterprises have VNets in Azure, and they use VPN gateways to connect these VNets to their corp backend, to their corp network. So they have a kind of virtual hybrid network where all the PCs and servers, either if they are running in the VNet in the cloud or on premises, they can reach each other through proper IP routing. In my case, the VNet is just a standalone VNet. I don't have any VPN gateways because VPN gateways are not a topic of my session today. The second statement here creates a subnet. A subnet is, as the name suggests, again, it's both statements here. The first one just updates the existing subnet, and the second one creates a new subnet. Subnets are IP ranges within the global IP range of the virtual network, and those subnets, they have certain properties. And here I have the first tip for you. Create a separate subnet for your private endpoints, because then you have a natural place for creating all your private endpoints. And in practice, you don't have just one for a SQL database, but you have many. Because non-trivial applications, they use databases, they use message broker, they use caching servers like Redis cache, they use NoSQL databases, they use, many other PaaS services that are super useful in Azure. And therefore, you will have many private endpoints. So create a separate subnet for the private endpoints. And that is a limitation that you have to adhere to. The private endpoint subnet, for this private endpoint subnet, you have to disable the so-called network security policies, network security groups, sorry. Network security groups are a way of protecting your VNet and subnets, but for subnets with private endpoints, you have to disable network security groups just for the subnet. Don't worry. You still can use network security groups for other parts of your application, for the resources in Azure, but just not for this subnet. Now I will have two subnets. One is the public subnet where my public API will live in, and the second one is the private subnet where I will have my private endpoints. Okay? Good. It is completed. We can quickly take a look inside of our Azure here. Let's see, this is the resource group, and if I refresh it, you will see here I have my virtual network, and if I go to the subnets, you will see that I have a public subnet, the private endpoint subnet, and for the sake of completeness, if we have enough time, I will do a final demo with a virtual machine. I also created a subnet for a virtual machine. Typically, you should avoid virtual machines in Azure because it's like having some Tamagotchis in the cloud that you have to feed and pet and things like that. Avoid virtual machines. Try to go platform as a service and serverless. But for one of the demos, I want to have a virtual machine to show you a little bit what's going on inside of our network and network routing, and therefore this is just for demo purposes. So worked well. We now have a VNet in Azure. Okay, next one. I would like to add my web apps, the public web app and the private web app, to my VNets. Let's do that. I told you that the public web app should be able to reach resources inside of the VNet, of course, because the public web app wants to access the private web app in the backend. But you might ask yourself, why does the private web app need dedicated access to the VNet? Rainer told us that he is going to create here a VNet around the private web API, and the private web API is inside the VNet. And now I have to be honest with you, this is not possible. It's not possible, at least with the tools that I use here, to move the private web API inside the VNet. Why? Because this is a platform as a service offering. I can't take the virtual machines that are somewhere below this private web API ran by Microsoft. I cannot take them and move them into my VNet. So the private web API, to be very specific, will not be part of my VNet. The private web API will be out of my VNet. But what I will have is I will get a so-called private endpoint let's make it like that, a private endpoint inside my VNet, but it will just be a private IP address. And when I access this private IP address from the public web API, Azure will make sure to securely transmit the traffic directly to my private web API, which in fact runs out of my VNet, but the private endpoint is really as the name suggests, the private endpoint with the private IP address through which I can securely communicate with the private web API. But if I run code inside of the private web API and this code would like to access the SQL Server, it would not go through the VNet again, because the private web API would use the public internet to access the SQL DB. Therefore, I have to integrate the private web API in the VNet too. So the correct drawing would look something like this. The private web API would have a private endpoint here. The public web API would access the private endpoint here, and the private web API, because of the VNet integration, would, if I put it that way, use again a private endpoint of the database to access the database inside the VNet. So essentially, this service here, this platform as a service offering is still running outside of my VNet, but through the private endpoint, I force the private IP address to be addressable inside of my VNet. And through the private endpoint from the SQL DB, I again create the private IP address inside of my VNet, and then through the VNet integration of both app services, I force them to tunnel their traffic through or inside my VNet. And therefore, I get exactly what I want. I run my code in PaaS services, in multi-tenant PaaS services outside of my VNet. But through the private endpoints, I can make all the network traffic running locally inside my address space, where I can control what's going on and where I can add any kind of network security infrastructure that I would like to. So this is the reason why I need to integrate here both app services inside of my VNet. Good. And now we can start to create the private endpoints. Let's create the first one, this one. This one, again, let's do the code walkthrough while it is running. This one creates a private endpoint for our SQL database. So we are essentially creating a local IP address inside of our VNet, and this local IP address will point in the backend to the SQL database PaaS service that belongs to me and that stores my precious data. So it gives me a private IP address inside of my VNet. The thing that is standing down here, I will not go into the details. It's just a bunch of querying to get to the local IP address. I simply would like to print the local IP address at the end of my script on the screen. And it should be visible in only a few seconds. I will take a sip of water and then we should see the results, hopefully. Yeah, this is the name of the database, and the next should be the IP address. And here we are. As you can see it here, we now have a private IP address. So my database is still running outside of my VNet, but now I have a private endpoint inside of my VNet. That's the first thing. We can also take a look at that in the portal if it already completed. Here it is. This is my private endpoint, and if I go to DNS configuration, we'll talk about that in a second, we see that we currently have a single managed database with the IP address 10.0.0.4, a local IP address. Good. Now, the next big topic, I will again select that one and run the script. The next big topic is DNS, because having a private IP address is one thing, but making use of it is another thing. Because you see, databases and also web APIs and so on, of course, I use TLS for them. And therefore, I can't really do a lot of interesting things with IP addresses because my DNS, I need DNS names in order for the certificates to work properly. Okay? So therefore, I need to apply some magic so that when somebody inside of my VNet accesses the SQL database, this somebody will not go through the public IP, but through the private IP. And if somebody outside of my VNet accesses the SQL database, this somebody should get the public IP address, both under the same name. So the DNS resolution for the name of the database should run differently depending on where I am, inside of the VNet and outside of the VNet. And this magic, I always call it Harry Potter programming, a little bit of fairy dust, and it just works. This magic is provided by Azure DNS. Azure DNS is the DNS system of Azure, and Azure DNS knows something which is called a private DNS zone. Private DNS zone means that I have a DNS zone where I can register private resources, and in my case, I register DNS names with private endpoints inside of that private DNS zone. So what I do here, to make a long story short, I create the private DNS zone with a certain zone name. You see that one? And at the end of the day, you will have a dedicated DNS zone name for every type of resource that you use in conjunction with private endpoints. So this is the one for SQL databases. There will be a different one for Cosmos DB, a different one for Postgres, a different one for Azure Machine Learning, a different one for Key Vault, and a different one for Azure Blob Storage, for instance. So you have one DNS zone for every type of resource which you would like to do name resolution privately for. Then you can connect this DNS zone with your VNet of choice. In our case, we only have one VNet, so the choice is very limited. We just connect this one. We link the VNet to the DNS zone so that Azure can do DNS resolution inside of this VNet. And last but not least, we add our existing private endpoint to the private DNS zone so that Azure will automatically register every SQL database that we have inside of our SQL database service to the DNS zone so that DNS name resolution will work properly. If everything worked out nicely, we will see it in a second, then we can go here to the private endpoint again, go to DNS resolution, here you see it, and then you will see the output here for the private DNS integration. So now you see that we have the fully qualified domain name, and here you see that we have the IP address. And this is stored inside of the private DNS zone that you see here. So if I click on this private DNS zone, you will see that currently we have a single database server, and we have an A record here which points the SQL database server to this IP address. And that makes the whole magic work. Now, whoever runs inside of my VNet, or whoever sends traffic, routes traffic through my VNet and uses the DNS system of my VNet, will now end up using this private IP address for my managed SQL database, my managed Cosmos DB, my Azure Machine Learning, all the services that Azure can do. But if I come from outside, I think I still have it here, if I still do my dig here, nothing really has changed. Well, a little bit has changed. If you scroll up a little bit and scroll down a little bit, you see that a little bit has changed. So if you scroll up here, you see that my database name before directly was a CNAME called databasewindows.net and so on. And now suddenly, by creating the private endpoint, we have an additional CNAME indirection here. Now we go through a CNAME which has the word private link in it, but still we end up with a public IP address. However, if we run exactly that DNS query through our VNet, through the Azure DNS name resolution system inside of my VNet, I will not end up with this IP address, but I will end up with this IP address because of the DNS integration. This is what I meant with it is important that we integrate DNS and private endpoints in order to make the whole thing work. To be very specific, if we create private endpoints Of course, we can still access the SQL database over the public IP address, over the public internet if you want to. We can still open the firewall, for instance, for certain IP addresses, maybe a business partner who can't access Azure for whatever reason. I can open selectively certain public IP addresses to access the SQL database. But if I want to be completely private, I can simply lock down the public IP address and only allow traffic to go through the private IP address. That's now up to me. But many people misunderstand the concept here, and they think that by creating a private endpoint, we are removing the public endpoint. That's not true. We just add an additional endpoint, and we have to make sure that the firewall is locked down. To be honest, by default, it is locked down completely, but we could punch hole into this firewall if we need to. Now let's run the second. Let's create the second private endpoint. That's for the backend API, this one. This is now, just so that you can follow along, let me show you that here, that in my beautiful ASCII art, the first private endpoint was the private endpoint for the SQL database. And now we are creating the private endpoint for the private web API so that the public web API does not need to use the public IP address to talk to its backend. Okay, this is what's currently running. Okay, and it should only take a few seconds and we are good. And then we have to do exactly the same thing again. As you can see it here, down here, we create the second DNS zone because now we have a new type of resource, you see it here, that should be integrated with our private endpoints. In contrast to before, it is now called privatelink.azurewebsites.net. We register our private endpoint with this DNS zone, and exactly the same story applies that I had before. So in a few seconds, our first script should be done, and we should see the local IP address of our backend API. And it's fetching the IP address now, and we should see it now. Here you have it. So this is the IP address of our backend API inside of our VNet. Very well. And I will now run the DNS integration. Here, this one. Let's go. Yeah. DNS integration should also be done in a second. But while this is running, I prepared something for you, a more complicated, more elaborate environment that I created for this talk today. This is a demo for instance, data science. I created it up front, and as you can see, it contains more resources. And the point that I wanted to make here is this one. In this scenario, I use way more resources in Azure. I use Azure Machine Learning. I use a so-called data lake. I use Jupyter notebooks. I use, for instance, Power BI. Maybe you know the Power BI system. Maybe it is in use in your companies to do business intelligence. I use Key Vault and so on. And here you can see the different DNS zones for every type of resource that I'm using here. And I can connect all these things to my VNet, and I can create a way more complicated, a way more elaborate environment for data science with Jupyter notebooks, with VMs, with compute instances, including GPU support for, I don't know, some deep learning stuff, with Key Vault for hardware security modules storing some secrets and doing encryption, for instance, with Data Lake storing petabytes of data for your data warehouses, and use private endpoints for all of these systems to build a completely private environment which can only be accessed through, for instance, a VPN gateway from my local company network. So I have a private environment in Azure, although everything is running in public PaaS services, which would otherwise require me to use public endpoints through public IP address, and I would really have to embrace a zero trust networking approach here, and not all companies can do that. So this is a more advanced scenario that I wanted to show you here. It really works fine. So we can go to here, we can go to the network, to the for instance, a Jupyter notebook, and we can run a Python script. Imagine that we are a data scientist accessing our data lake from a Jupyter notebook. And as you can see here, we are still getting a private IP address. So everything is perfectly fine. Let's go back to our example, and it is now done. The last step that I have to do, and that only takes really a few seconds, the last step here is to configure the web apps so that they send the network traffic through the VNet instead of trying to reach the other partners, the backend API and the databases, over their public IP addresses. Let me run this. While this is running, I would like to draw your attention to these two settings here. The first one is kind of interesting, this one. It is a pointer to the DNS server of Azure. The Azure DNS server always has the same IP address, and if you work a lot with Azure, you probably know it by heart. 168.63.129.16. That's the recursive Azure DNS system. And with this setting here, I force my APIs to use the Azure DNS server, and with the second setting here, I am forcing the code that is running inside of my API, of my app service APIs. I'm forcing it to send the network through the VNet, and with these two settings, I really make my private endpoints work, because now through the Azure DNS, it should resolve the DNS names to local IP addresses, and with the second setting, it enforces traffic to flow through my VNet, and therefore I'm no longer using the public IP addresses. So if I'm a security-aware person, which I am, then I can lock down the databases. And this is what I do here. I'm locking down the firewalls for this, in this example, for my SQL database, to make sure that nobody can access this database over the public internet. I disable public network access completely. Nobody can access it. That saves me from a situation where I might have made a certain mistake while configuring things, and suddenly people can access my database, although I didn't want to. Now, we are nearly at the end of the session. While we are doing the upcoming demos, I will now create in the background a little virtual machine here, and scroll up. While this is running, forget the virtual machine, that will be my last demo here. While this is creating, I would like to show you that our APIs are still available. First, let's try the private web API. This one is the private web API, and let's run it. Oh, I forgot to set my settings here. Give me a sec, please. So the name should really resolve, and here it is. Run it. I was just missing some variables that I forgot to set here. This private web app wasn't set. So give it a sec. Come on, we have 5 minutes left, so it should work. Let's run this one. Curl, private web app, let's see what's going on. Isn't finished. Okay, it takes a while, good. So if it doesn't work like that, I will simply copy the name from here, and we'll do it like that. That's fine too. So again, come on, curl this one, and woohoo! Yeah, this error is by design because I wanted to show you that it's no longer possible to access the private web API from outside the VNet. That is by design. That was an error I was really fighting for hard to get, because this is what external people should see. I am here in my office in Austria, and therefore I cannot access the backend API. But now things will become interesting, because now I would like to access the public web API. So let me quickly not wait for the scripts to finish. Let me quickly copy the name of the public web API. Here it is. Let's clear it here. And then let's do a curl statement with the public web API, something like this. And woohoo, that was exactly the demo that I wanted to show you. So you see the difference compared to before? Now, my public web API accesses the backend, the private web API, no longer through a public IP address, but through a private IP address, the 10.0.0.5 IP address. And the private web API accesses the database, here you see the database name, again through a private IP address, and the SQL statement still works. So I showed you here with this single curl statement the entire chain from the public web API accessing the private web API, accessing the database, and only the public web API, which should be publicly available, is publicly available. Let's see if my VM has already started. Yes, the VM has already started. That is good. So let's do a final demo in the last 3 minutes, because I wanted to show you how this really works. And by now having a virtual machine inside of my VNet, I can do a dig statement. I can do name resolution in the VNet by SSHing into the machine. Let me quickly fetch the IP address of my virtual machine. I could have automated that, but that is just the demo part, so it's perfectly fine to just copy the IP address. This is the IP address. So let's go here and do the following. Bum, and bang, and good. And run the first one. Oh my God, can I remember the password? Hopefully I can. Yes, I can. And this is the point that I wanted to make here. See? Inside of the VNet, that is the view of inside the VNet. Inside of the VNet, the name is resolved using a CNAME to the same name, but with the additional text private link. And this private link now goes to my private DNS zone. And in the private DNS zone, we now find the A record in DNS. And this A record points to my private IP address. If I do, just to make the story complete, exactly the same dig statement, I will take this one again and go here in my local environment here, not dog, dig. You will see it looks, the first step looked similar. But we end up with the public IP address. Different view inside the VNet and outside the VNet. And that is exactly what I wanted to show you. So what should you take away from this demo that we did here in the last 45 minutes? You should take away with you that private endpoints are a way of embedding a private IP address in a VNet, an addressable IP endpoint for PaaS services, platform as a service services, which don't belong to you. So you cannot move the virtual machine inside the VNet, but the private endpoint gives you a way of addressing them securely over a private IP address, and therefore you can lock down the public access. First one. Second one, private endpoints are deeply integrated with Azure's DNS system to make routing work properly. And believe me, in non-trivial enterprise networking environment, it is not trivial to set up DNS and network routing with private endpoints and VPN gateways and hub spoke network architectures and so on. So don't take away from this presentation that everything works always smoothly and is a piece of cake to set up. That's not the case. It's a non-trivial thing to configure if you are in a non-trivial network setup. For simple setups, everything is simple. Complex setups are possible, but it's not that simple to set up. With that, I am lucky because the end of my content is at exactly the right point in time. We spent 45 minutes. I enjoyed giving this talk to you. I hope you enjoyed listening to me. I still don't see the chat window. I hope that there aren't too many questions open. If you have questions which I haven't addressed, again, please go to rainerstropek.me. Connect to me via LinkedIn, Twitter, or something like this, and I will be more than happy if you send me a direct message to answer all your questions. With that, I am through, and I would like to give back to the organizers, and I hope everything went well with the streaming. Did it?